Hello, student. Hi, how are you? So, let us discuss today about antenna. Okay, how the antenna radiate. Okay, so that is what how antenna how antenna radiate how antenna radiate how antenna radiate. Okay, so today we are going to see this topic. Okay, how our antenna radiate actually. What is antenna? As you know very well, antenna is nothing but it's just a conductor. Okay, so antenna is a device the which convert electrical energy into the electromagnetic energy. Okay, so this is my antenna. So let's say this is my antenna. Okay, this is antenna. What this antenna do? So this antenna will convert my electrical energy. Electrical energy means voltage and current. Voltage and current into electric electromagnetic wave. Okay, electromagnetic wave. Voltage and current oscillation into electric and magnetic field oscillation. Okay, VI oscillation into EM wave. So this is about antenna. What is antenna? Antenna is a device which convert VI oscillation. VI means voltage. VI means voltage, and I means this is current. Current. Okay, current. So this is antenna. Antenna is a device which convert the voltage and current oscillation into electromagnetic wave throughout the space. Throughout the space, this is what antenna. Now we will see how this antenna actually radiate. How the antenna radiate. See, basic concept is how the antenna radiate. Let's say we have a what charge. We have a charge. Okay, so this is my charge. Wherever the charge is there, the field is there. This charge is like surrounding this. There is a field. What type of field? Electric field. How we can feel that electric field? That is nothing but force per unit charge. Okay, so there is a force. So this is my charge. Okay, so near about there is another charge. Let's say there is a Q2 charge, Q1 charge. Okay, so there is a Q charge. Okay, surrounding this Q charge. So it is what it is feeling some type of force surrounding this. It radiates some type of force. Okay, some type of force is there surrounding this. So these are field. These are what field? Electric field. These are electric field. The space varying electric field. And this charge is what? Stationary charge. This charge is stationary. Why I'm discussing about this charge? Because this is only the main source of what? Main source of radiation of an antenna. Radiation of antenna. So that's why this is a charge. This charge is stationary. This charge is what? Stationary charge. Stationary means there is a space varying field. Space varying field means space varying electric field. So this electric field is nothing but force per unit charge. Force per unit charge. How much force is there? How much force is there when any other charge will come in the surrounding of this charge. Okay, so it will feel some force. So there is some force, and that force is nothing but a field. That is electric field. Means force per unit charge. So this is my field. So that is electric field. So we can say that now this is a rest charge. Charge at rest. When the charge is at rest, then there is only space varying field. What? Space. Then there is only space varying space varying electric field. Space varying electric field. Space varying electric field, you can say. Okay, so space varying electric field when charge is at rest. Okay, so now if I will say that this charge is what? This charge is moving. Okay, now this charge is what? This charge is moving with what? Moving with constant velocity. Moving with constant velocity. Okay, this charge is moving with constant velocity. constant velocity. If this charge is moving with constant velocity, then there is what? Then there is a then there is what? Static magnetic field. Constant means this charge is moving with constant velocity. Then there is a generation of magnetic field also. When this charge will start moving, then there is a generation of magnetic field of constant magnitude. Magnetic field of constant magnitude, and electric field is also a constant magnitude. Means it is generating DC current. Okay, so then there is a DC current. When this charge will move with constant velocity, then there is a generation of constant current, and that constant current is nothing but DC current. DC current, DC current that we can get from moving charge with constant velocity. Velocity is what? Velocity is constant. Here, velocity of the charge is constant. If the velocity is constant, then there is a DC current. Then there is a DC current, and it will generate the magnetic field of constant amplitude. That magnetic field will not vary with time. Okay, so that will not vary with time, and it is constant. Okay, so now we will see. Now we will see what? We will see the charge. If this same charge will what? Will move with different velocity. Will move with different velocity means dv by dt. dv by dt. Okay. First we have seen dx by dt. dx by dt means charge is moving with constant velocity. So this is my velocity which is constant. Okay. So that time there is a DC current. DC current means there is a magnetic field, also there is an electric field, but both have constant magnitude. Means with constant velocity, it will generate DC current. Now this same charge is moving with a different velocity. It is moving, but its velocity is not constant. Not constant means velocity is changing. Velocity changing means what is this? Acceleration. This is what? Acceleration. When charge is accelerating, deaccelerating. So it is oscillating. Okay. So there is a oscillation of charge. Once the charge will start oscillating, then what? Then from Maxwell equation, as we know very well, del cross E is equal to minus dou B vector y dou t. Dou B vector y dou t. Means rate of change of magnetic field generate electric field, and del cross H is equal to, that also we know, del cross H is equal to sigma E plus dou D vector y dou t. Okay, dou D vector by dou t, or you can say dou E vector by epsilon dou E vector by dou t. Dou E vector by dou t. See here, change of electric field. Change in electric field generate magnetic field. Change in magnetic field generate electric field. Yes, electric field. This is because of what? This is because of acceleration of charge. Acceleration of charge. Once the charge will start accelerating. Once the charge will start accelerating, then it will generate the magnetic field which is varying with time. Okay, so the main concept why I'm discussing about, because this is only the origin of radiation of antenna. Before knowing the radiation of antenna, how the antenna radiate, so we should know first about charge. Okay, first about charge, behavior of charge. What is the behavior of charge? Okay, so whether this charge is at stationary, or this charge is moving with constant velocity, or this charge is moving with different velocity. Okay, so the oscillation, so there is a change in magnetic field and electric field. So the antenna will radiate what? Electromagnetic wave means electric and magnetic field both are changing with time. Okay, both are varying with time. So that is only possible when the charge will oscillate. When there is a charge, there is a oscillation in the charge. Means charge is accelerating or deaccelerating. Okay, once the charge accelerating, deaccelerating, then with the help of Maxwell equation, we can say that if there is a change in charge, if there is a change in the velocity of charge, then there is a change in the electric field. Okay, so definitely it will generate electric field. There is a generation of electric field, and this electric field is changing with time. So therefore, this change in electric field generate magnetic field, and change in magnetic field generate electric field. So this process will go on. this process will go on. Okay, so go on, and it will vary with time. It will vary with time. So okay, so this is the process of, actually this is the process of generation of time varying electric and magnetic field when the charge start oscillating. When the charge start oscillating, or charge is moving with a different velocity, means charge is either accelerating or deaccelerating. Okay, so through this by taking this as a base, we can now discuss about antenna radiation, how the antenna radiate. Okay, so this is actually main concept. Okay, so before going to directly to antenna, so that's why we should know about charge. Okay, behavior of the charge. What is the behavior of the charge? Okay, if the charge is not oscillating at all, means discussion about antenna is useless. Okay, without knowing the behavior of the charge. Okay, so that's why we have spent this much time for about behavior of charge. Okay, so we are now confirmed that when there is a change in the electric field and magnetic field, means that will get radiated from the antenna. Okay, so which is possible only when the charge behavior is oscillatory behavior. When the charge has oscillation type of behavior, means charge is what, accelerating or deaccelerating. Okay, its velocity is changing with time. So now see here about antenna. I have one conductor. Let's say I have one conductor. Okay, I have this conductor, and in this conductor I will apply some supply. Okay, some supply. Let's say I am applying first dc supply to what, dc supply to this conductor. I am applying dc supply to this conductor. Okay, this conductor. Now there is a positive charge and negative charge. What this charge will do, this charge will move to each other. Okay, they will come to each other. Okay, so they will start coming to each other. Then what is there, there is a generation of generation of current. Okay, so this will give us what, current, flow of current. Okay, charge is moving like this, like electron is moving like this. Okay, these are movement of electron in this direction. Then current is will flow in this direction, and this current is nothing but dc current, because we are applying the dc supply. Okay, so wherever there is a current, then there is a generation of magnetic field. There is a generation of magnetic field. But these magnetic field are constant magnitude. These magnetic field have constant magnitude. What, constant magnitude? So these magnetic field are not changing with time. Okay, so this is dc magnetic field, and this magnetic field is not changing with time. Okay, so then there is no generation of time varying electric and magnetic field. Okay, so then this will not work as an antenna. Okay, so this conductor, because we are supplying this conductor with what, dc source, so therefore there is no acceleration. This current is dc, means current is constant means velocity is constant. If we differentiate this, velocity means acceleration is zero, so there is no acceleration of the charge. Wherever there is no acceleration, means behavior of the charge is not accelerating. So then the antenna, this conductor will not work as an antenna. Okay, so now this conductor will not work as an antenna. So now if I will take same conductor. Okay, so and there is a positive charge and negative charge, and I will apply here what, ac supply. Okay, so by applying ac supply to this conductor, and this charge will start oscillating. Okay, so this charge will start moving close to each other. Okay, close to each other. Then there is what, then there is a ac current. Okay, so ac current, then there is a ac current. Now ac current, so this is my ac supply. Okay, once there is a ac supply, then this conductor will what, this conductor will start radiating. Okay, so there is oscillation. This conductor will radiate. How this will radiate, how this conductor will radiate, now we will see. Okay, so up to this we should know, up to this we should know. And this is my, let's say this is my vdc. Okay, dc, ac voltage source means there is a time varying supply. We are giving the time varying supply to this. Okay, so we are giving time varying supply to this. Okay, so now this conductor will work as what, this conductor will work as an antenna. This is a conductor. conductor. Okay, it will work as an antenna. It will radiate, it will start radiating when this conductor radiate. Okay, so the once we are applying the supply as AC supply. So AC supply means which is changing with time, which is changing with time. Okay, if we apply this to this conductor, then this conductor will start radiating. Conductor will start radiating. When the conductor radiate, that we know now. Okay, so now we will see when this conductor actually radiate. See, I am applying here AC supply. Okay, I have applied here AC supply. Okay, so now let's see, let us make this somewhat smaller. Okay, so this is when this conductor radiate. This conductor radiate? No, not at all. Why? Because see here. So see here. If you see, this is open. This is open. Okay. So this is my like transmission line. Okay. So this is what conductor. Conductor means it's like a transmission line. I have applied here AC source. AC source. Okay. AC source. Then there is a flow of charge carrier. Okay. So there is a current flow. But here it is. Here it is what? It is minimum. So here this current is minimum. Okay. So minimum. If you see this current is flowing here. Okay, here current is flowing IAC. So that is the function of time I of t. So let's say this is Ix of t, and here is Ix of t. Okay, so then there is a reflection to this what transmission line. This is my transmission line, conducting line. Okay, conductor line. Okay, so per unit per meter. Okay, so the length of this conductor is in the order of meter. Okay, so here if you see, there is a reflection, back reflection, because this is open circuit. If we will calculate here reflection coefficient, as reflection coefficient we know very well, ZL minus Z0 divided by ZL plus Z0, ZL plus Z0. Yes, ZL plus Z0. If you will see, this reflection coefficient is coming -1. Okay, so -1, it will reflect all the all the current within this transmission line. It will not radiate. This conductor will not radiate. Okay, so because if you see, supply is what? Supply is AC supply, and there is a positive charge, there is a negative charge. One cycle, like I am applying this supply. Okay, so I am applying this supply. So there is a positive polarity, negative polarity, positive polarity, negative polarity. So here also this polarity will change. Okay, frequently this polarity will change. Okay, and there is a reflection back. There is a reflection on the transmission line. There is a reflection on the transmission line. Okay, so because why? Because there is a equal amount of what? Equal. This is positive, negative. Okay, so during during this, if you will see, this here. So let's say this is my supply. Okay, so this is my conductor, and here this is my I x of t. Let's say I x of t is okay in x direction. There I have applied AC supply, and this is my AC supply. During positive, there is a generation of positive charge, and there is a negative charge. Okay, so during negative, this is now negative. This is positive. So this is positive. Then there is a negative. There is a positive. Then okay, so this is positive. This is negative, and here negative, here positive, here negative, alternate. Okay, so they are generating alternate because it is AC. Okay, positive, negative. This is positive to negative. These are my electric field. What? These are my electric field. Similarly, there is a generation of magnetic field. But these electric field, what? Electric field are cancelling with each other because they have equal amount, because they are equal in magnitude. Okay, so there is a equal amount of what? Equal amount of positive electric field. Okay, so this there is a equal amount of this electric field. Okay, so which is moving from higher potential to lower potential to higher potential, means these electric field are cancelling with each other. Okay, so net electric field within this conductor is 0, so it cannot radiate at all. This conductor will not radiate at all until and unless their magnitude should be different. Okay, so these electric field which is directing from positive higher potential to lower potential, and this electric field positive from lower to higher, if these electric field are different in magnitude, then there is a possibility of radiation of this conductor. Okay, so radiation through this and through this transmission line. Otherwise there is no radiation at all. Why? Because both are in equal strength, both have equal magnitude, and these are what, these are internally cancelling with each other. So therefore net electric field is zero. Net electric field is zero. So uh, so it cannot radiate. Okay, so this cannot radiate through this transmission line. Okay, so there is no radiation, all the radiation will get cancelled within each other only. Okay, so there is a net electric field is zero. If no electric field, no magnetic field, no radiation at all, no radiation at all. Okay, so this is what main concept. Okay, main concept, the transmission line will not radiate, transmission line not radiate. Why? Because the net electric field itself will get cancelled, because of equal amount of positive electric field, negative electric field will get cancelled within this transmission line. So that is the main purpose. What we should do then, what we can do so that this transmission line will start radiating, this conductor will start radiating. See the technique what we can do for that. For that we should do, see here. So this is my supply. Okay, so this I have given the supply voltage. Now what I will do, so we should just bend it. Okay, so just give the tapering or flaring when we will give what, when we taper this. Okay, when we taper this and, or we clear this end by small amount, then you see here, let's say there is a positive negative, positive negative negative, negative negative, positive positive. Okay, so now see here, positive positive, negative negative, and this negative negative, positive positive. Now see, within this, up to this, there is electric field. Inside the electric field, these are, these electric field are cancelling with each other. Okay, up to this all electric field will, net electric field is zero. Up to this net electric field is zero. But here if you will see here, positive to negative. Okay, positive to negative, and this is negative negative, positive positive. So okay, so this is positive positive and negative negative, positive to negative, positive to negative. If you see this magnitude, see this electric field magnitude and this electric field magnitude are different. Okay, so there is a difference is not equal to zero, difference is not equal to zero. So whatever the difference is there, that will get radiated from this what, from this tapering portion, but here, same here, if you will see, so there is what, equal amount of electric and electric field. Okay, so there is equal amount of positive side electric field and negative side electric field, both are cancelling with each other. But if you see here, there is a different amount. See, positive to negative, this downward electric field magnitude is larger than that of this upward electric field. So whatever the difference is there between this, that difference, that amount of what field will get radiated out of this, and there is a generation of magnetic field also. But there is no generation. Why? Because itself a electric field is cancelling within this conductor only. But there is no cancellation. Why? Because the difference is not zero. Difference of the electric field in opposite direction is not zero. So that's why it is able to radiate. Okay, so this portion will get radiate, but this portion will get cancelled. The field within this portion will get cancelled each other, but the field within this portion, within this tapering portion or flaring portion, will get radiated. Okay, so this is behaving like what, this is behaving like antenna. So this is my antenna. Okay, so now what we should do, maximum, if we will do maximum tapering. See here, if I will do maximum tapering 180 degree, maximum tapering, you see 180 degree tapering I have done. Okay, so this is flaring of an antenna. And okay, so I am bending this antenna 180 degree. Okay, it's now an antenna is nothing but conductor. Okay, so I have bent. Okay, I have bent this. So antenna is nothing but radiating conductor which radiate. The conductor which radiate the EM wave is nothing but antenna. Okay, nothing but antenna. So what I have done, now I have this portion fully, about 180 degree, I have given here tapering to this conductor by 180 degree. Now if you will see here, positive, this is negative, this is positive, negative. Okay, so positive, positive, okay, positive, positive, negative, negative, positive, positive, and here negative, negative. Now see here, now the tapping is full. Okay, so now there is a large electric field or magnetic field. If we see this, positive to negative, positive to negative, here positive to negative, positive to negative, negative. Okay, positive to negative, positive to negative. Now it will radiate. See, both have what magnitude different, both have different magnitude. Okay, so there is a difference, that difference will get what, radiated. Now how this will radiate, this will radiate like this. If you see here, if you will see here, this one, positive to negative, positive to negative. Okay, positive to negative, this is negative, this is negative, negative. Okay, so these are positive, positive. So this is positive to negative, negative. Okay, so now this is my field, em wave. Okay, so this is my another wave front. This is my first wave front, and this is my second wave front. Okay, this is my second wave front. Okay, so this will get detached from this conductor. How it will detach? See here, how it will detach, how actually em wave form. See, this is what, this is my antenna. Okay, so this is my antenna, this is my antenna. See, here I have applied AC. I have applied AC supply. AC supply. Now these charge, when this charge, let's say this charge, positive, negative, positive, positive, negative charge. So positive, positive. So when the charge move closer to each other, closer to each other. Okay. So let's say there is only positive charge, there is only negative charge. When this negative or positive charge will come closer to each other, okay, closer to each other. So here, here positive charge, here negative charge, negative charge. Now see here how this wave front will form like this. Okay, so this time I am showing only one. Okay, so there is a so many wave front. Okay, so for understanding purpose I am just showing only one. Okay, positive to negative, positive to negative, negative. How this wave front formed. So how, this is my what, electric field, this is what, electric field. Okay, this is my electric field. Now this charge is coming very close to each other. Okay, so charge is coming very close to each other, this is positive, negative. Now this charge is coming very close to each other, and this electric field is trying to form close loop. Okay, so now this charge will come again much closer to each other, and this is my positive, negative charge. Okay, so this is what, this is my electric field. So again this charge will come very close to each other, they will meet with each other, they will meet with each other. Okay, so this is my closed electric field, closed loop electric field. So does electric field form closed loop? Yes, electric field form closed loop when the charge become neutral, when this charge become neutral. Okay, once the charge will become neutral, and that time, that point of time, this electric field will get detached, this electric field will get detached from what, from antenna, from antenna. Okay, so then there is a formation of another electric field. Okay, so this is, I am showing this is positive charge, negative charge. These positive and negative charge are coming very close to each other, and in this way this electric field is trying to form closed loop. See, electric field form the closed loop, electric field form closed loop when there is a neutral charge. Okay, when the net charge is zero, then there is a formation of closed loop electric field, which will get detached from this antenna. Okay, so this is my electric field. Okay, so this will get detached from this antenna. Okay, so this is how the antenna radiate. Actually this is how the antenna radiate. Okay, so this is the actual process that we have, that I have shown you. Okay, so now in this way only this electric field will get. So this is my first, let's say this is my first wave front that has detached from this antenna, and there is a formation of another wave front. Okay, so this will get detached like this. Okay, so there is a so many wave front, this wave front. So these all will get detached as the charge, as the charge is neutral. Okay, so now this will what, this will apply the force to this will apply the force to this wavefront, and this wave, and these will get radiated. Okay, so through the space in this way. Okay, so what is the way of process? As the charge is coming very close to each other, then then this electric field will form the closed loop. Once they will form the closed loop, where at the point where the charge will get neutral, this net charge will get zero. On that time, this electric field will get detached from this conductor, and it will get radiated. It will get radiated throughout the space. And there is a lot of like 10,000 and lakhs and lakhs of what this wavefront will get generated from this antenna. Okay, as this charge is oscillating means this wavefront are forming. These wavefront are what transmitted throughout the space. Okay, so this is actually how the antenna radiate. How the antenna radiate? What is the process? We are applying the AC supply to the conductor. Okay, so to the conductor, if you will take the simple conductor like this, it will not radiate at all. Why it will not radiate? Like transmission line, why it will not radiate? Because what? Because there is a electric field, net electric field within this conductor is zero. Okay, because equal amount of positive electric field, negative electric field, they will get cancelled within the conductor, and therefore there is no formation of electric field outside this conductor. Okay, so therefore this conductor will not radiate at all. Okay, so what is the technique? What is the technique that we can make this conductor to become radiative? For that, what we will do? We just flare. We just taper this transmission line from its corner side. Okay, so we just taper it. Once we will taper, so then what happen? The electric field that will get generated within this tapering portion is different. Okay, positive electric field and negative electric field, there is a difference, and that difference is not zero. Okay, so that's why it will start radiating outside. So this is the basic about how the antenna radiate. And what is this antenna? Antenna is nothing but it is a simple conductor. It is a simple conductor which will radiate the electromagnetic wave. When it will radiate the electromagnetic wave, what is the what is the origin behind this? The origin, what is the main source behind this, is nothing but oscillation of charge. Okay, we have to make the charge, when the charge behavior is oscillating, accelerating or deaccelerating, that time it is possible for the conductor to radiate. Okay, so it is only possible, just we have to what, just we have to flare the side portion of the conductor. Okay, so we have to just bend. Okay, we have to just bend the conductor, bend this transmission line or conductor. So there is, due to this bending, there is what there is, then we are able to generate the electric field within this conductor of different magnitude. Okay, whatever the electric field is in positive direction, that has different magnitude than the electric field in negative direction. Okay, so in this way we are able to make this conductor radiative, and this is nothing but antenna. Okay, so this is basic about this antenna. So thank you very much to support my lecture. Okay, so this is all about antenna. So thank you very much.